Hello. Well, inside this box is a kit to build a model steam engine, and it's been sent to me by Stirlingkit, and today I'm going to be building the engine and then see what it can drive. So let's open the box and see what's inside it. So one box with a steam engine in and a mystery box with something else in it. So let's see what's in this first box here. Down over there. Instructions. Right, here we go. Many bits. They do look beautifully made as a starting point. So although Stirlingkit has sent this engine to me for review, they're not sponsoring the video and they've got no creative input. However, they are interested to see what sort of science and engineering can be introduced with the aid of a model steam engine. So let's get started. So I've done a little bit of unpacking here now, and so what have we got? Most importantly, we've got some instructions. So that's what we're going to end up with. It's a beam engine and a boiler on a base plate, and lots of screws. They've very helpfully sent a spanner and little screwdrivers and tweezers and things for very small parts, and rather helpfully, we've got some instructions on how to assemble it. They look rather good to me so far, but we'll follow them and find out what happens with that. So looking at some of the parts we've got here, we've got the base plate, we've got the boiler, but over here this is mainly the engine part. So we've got a cylinder, we've got a flywheel, we've got a connecting rod with a crank on it. I think these are the burners for the fire, the beam itself, with very beautifully made, I have to say, what's parallel motion there. We can look at a bit more of that in a moment. That's the piston itself. And rather excitingly, it comes with a governor on this engine. We'll talk about more how the governor works in a moment, but I think this governor is actually going to work, which is really rather fun because it's spun round by the engine and it governs the speed. So when you increase the load on the engine, the governor compensates and lets more steam go to the engine. So I think this is actually going to work, and we will find out in a bit. So as they said in the song, we'll start at the very beginning, a very good place to start. Item 1, and what I've done is I've set out the parts I need. We've got the cylinder, a base plate, some screws, a column, and so I'll put that together first of all. I think all these bits of metal are probably stainless steel, which will be rather nice because it will stay looking nice later on. Right, it's model engineering, so we don't do things up too tight. So I think we've now got step 1 of the build complete. So now we move on to step 2. We've got to mount this base part of the engine onto the base plate of the whole steam plant, and there's lots of little standoff columns, and so I get started on that. So we've finished stage 2 now, so we've got the base of the engine mounted to the base plate of the whole steam plant. So now we move on to stage 3. It's all pre-assembled here by the factory, which is very helpful of them. We have got the beam, the parallel motion and the piston, and this is actually a single acting engine. The steam is only going to push on the piston, it's not going to push it back down again, so it won't be as powerful as a double acting engine, but that's absolutely fine for what we're doing today. And we'll talk about later on about how Watt's parallel motion works and why it was so clever at its time. So I know this isn't steam oil, but I just want to put a little tiny drop of oil on the piston before it goes into its cylinder, because I don't want to damage it. Just do that, smear that round there, and then that is going to drop into there. So to secure the top of the beam, you'd call it the entablature if you were being posh. So to secure the top of the beam to that little spigot there, we've got a little grub screw which I have just dropped. Right, that's just got there now, and I need to make certain that this is free to move. So my first version of doing that was very poor and rubbish, however now that's correct. That now moves nicely. I've got it centred up nicely over the cylinder. So number 4 on the list is to put the bearings into the bearing pedestals. So I've got the bearings here. They are little ball bearings, so they have very little friction, very free running. And they are going to go in from which side? They are going to go in flanges outwards. So that was number 4. We've now got the bearings pressed into their little pedestals. Number 5 is going to be the valve going into the valve block on the side of the cylinder. Again, it's rather beautifully made because there's a ball bearing in there. Here's the little valve, and that is going to fit inside here. And we need to get it the correct way round. And I'm going to put a drop of oil on it just to help it not spoil itself when it's going in. So a little drop of oil on there. A huge drop of oil on there, no less. So I've now got the valve is in its valve chest or valve block, the beginnings of the crankshaft with its eccentric on there. So the next item we're going to need is the crankshaft and the flywheel. So we're really making progress now. Flywheel, crankshaft, and we're going to need some little grub screws to attach it all with. So here we've got the crankshaft. There's some little bits, little flaps that the grub screws can get a grip on, and I've looked at which way round it goes in. So it goes in like that, through that bearing, through the flywheel, through the other bearing. Oops, push the other bearing out, don't mind about that. If you put the grub screw onto the shaft, it'll throw up a burr, and then you'll never get anything to move around again if you need to. So there's the flywheel, just coming in onto the flat there. We'll put it in between the bearings like that. So we're starting to make a bit of progress now. I think you can see that is spinning rather nicely. That is courtesy small ball bearings, even a ball bearing in the eccentric to move the valve here. So we've now got the base plate of the engine on the base plate of the steam plant. We've got all the bearings done. We've got the flywheel, we've got the crankshaft, we've got the valve installed, and we've got the little pulley to drive the governor when that happens, and some sort of load afterwards, which might be what's in the mystery box. So it's running nice and freely, and on to the next stage. Part 8, we've got to assemble a connecting rod to the beam and the crank. So I've got the connecting rod here, and a moment ago I was struggling to do this because I didn't read the instructions properly, which says turn counterclockwise. So it's a left-hand thread. So now I can do that because I'm turning it the correct way, and that goes in there, so that it doesn't come undone when it's running is the idea, obviously. So that goes in there. I'll tighten up a bit in a moment, and then this is going to go in there. So we've got a little pin that goes through there. Look, so this is the pin, and it's got a little flat on it, so that's going to have a little grub screw holding it in place in there. So that can go through there. I can see the flat. Here is my little grub screw to hold that in. Put that in there. So here we've now got the connecting rod assembled, and it's running nice and freely. So now we've got the governor to fit. There's a little steam pipe which is a silicone tube, which saves lots of aggro with nuts and bolts and leaks. When I was a kid, they didn't have silicone tubes, so this is all new technology to me. So that's going to go on there. That is going to push onto the steam inlet, the cylinders. The cylinder one. Okay, so that's the governor in place. So now we've got to put the drive belt on from the engine to the governor. So as the engine spins, the weights fly out. As they fly out, they push the valve down, which restricts the supply of steam from the boiler through to the cylinder. And if this governor actually works to govern the speed, I shall be seriously impressed, because it's quite a fiddly thing to get a governor to work properly. So now we're making a start on the boiler, because here's one of the side pieces for the boiler. Are they the same? Are they the same? The sheet metal parts are really nicely made and went together very easily, although maybe not quite as quickly as this. Right, so now we've got the little silicone rubber tube to fit on there. I guess if we get an awful lot of pressure, the little tubes will blow off. That'll act as an excellent safety valve, but that's not quite the plan. And then that goes onto the steam inlet there. So we're getting pretty close to having a finished engine now. Let's have a look and see what else. Oh, we've got to do the burner. So we've got a tank. I guess we're going to run on methylated spirits. So we've got a tank. We have got two very delicate little burners. Now that's interesting. The burners, instead of having a wick made of sort of fabric material, they've got a wick made of very, very fine stainless gauze. So now we've got a finished engine, and I think now it's time to have a steam up. So I must put some fuel in there, some purified water in the boiler, and we'll light the fire and see what happens. So, exciting moment. We've got a finished engine. I hope I put it together correctly. What I'm going to do, first of all, I'm going to oil a few bits and pieces. So, I've got some steam oil here. It's from on the locomotive, but I'm going to put a little tiny drop of steam oil down this pipe here. This is just me doing this. It doesn't say this in instructions. Can I get the pipe off, having done that? So now we've got the moment we've been waiting for, which is to try the engine out. There's nothing much more exciting than lighting the fire in a steam engine for the first time, but we've got to do a few things first. So first of all, one, add water to the boiler and fill it till it's half to 3/4 full, and you do that through this little filling valve here. And so this is actually also the safety valve. So if you look here, there's a little spring, and the steam can push that up and let it out if there's too much steam pressure. And so I've got a little syringe here to fill it with. It says use purified water. This is water from the workshop dehumidifier, so essentially that is distilled water, as near as damn it. So that can go in there. Better to have it a bit too full and a bit too empty, because we do not want to run the boiler dry. Well, that's 3/4 full now, isn't it? That's fine. Okay, so what we do now is put the water filler and safety valve back in here. It's got a rubber seal to make it steam tight, so only literally just fingers, nothing more than that. If that isn't tight, we'll think about it later on. So now I'm going to just oil all the other little parts of the engine. So I've got some oil here, some little tiny bits of oil in all these little joints. Funny enough, this is chainsaw oil, and it might sound a funny thing to use that for a steam engine, but if you look at chainsaw oil, it's got an anti-fling property. You can see it goes all stringy. So even if it isn't the best oil ever in the entire world, if it stays in the bearing rather than falling on the floor, it's the best oil for the bearing. So we'll put a little drop in there. I want to put a little bit of steam oil in just around the top of the piston as well, because that really is the bit we've got to look after at the beginning. So now we've got to fill the alcohol lamp, the burner, with fuel. Alcohol is what they mean is methylated spirits in the UK, is what it's called here. And rather than making a mess and tipping it, I'm going to use a little glass syringe I've got here to fill it with. So I'm going to just do this. The advantage of the glass syringe, it won't be dissolved by the meths. So that can go in there. I don't quite know how much I need yet. Now, apart from the risk of burning your fingers on hot steam, which is not a disaster, the one thing to watch out for is that meths is a funny fuel. It burns very hot, which is why it's being used, but it has a pretty much invisible flame. So it's quite difficult to see meths, and if you spill it, you don't necessarily see where the flames are going. So I'm going to be quite careful. So now we've got the moment of lighting the fire. It's got meths in it. I've turned the lights down so that we can see what we're doing, and also to check it's actually burning. So I've got a lighter. Oh, that's going. Okay, so we'll put that into the firebox or the furnace. Here we go. It is in there. So the fire's lit, we've got water, and oh yes, that's getting uncomfortably hot to touch now. So just have to wait a few more minutes, and then hopefully we'll have some action. Oh, oh no, we're boiling now. Okay, we have got it boiling. And so the whistle's open there, so I'm going to get a burnt finger doing that. So I think I'm just going to shut the whistle. Aha. Okay, that was a cunning plan. So it is just starting to boil now. So we haven't really got enough pressure. Let's let it go for a bit longer. We'll judge a bit by what noise the whistle makes. Holy cow. It's definitely boiling. We're definitely in steam now. I think I put a little bit too much water in there. Right, enough for the frivolity of the whistle. So the steam, when it goes into a cold cylinder, condenses back into water. So they very thoughtfully provided a little drain valve here. So what I'm going to do is I'm going to just tweak open the steam valve a tiny, tiny bit and let a little tiny drop of steam go through. I'm just going to turn the engine over by hand, and there'll be, in a moment, there'll be some condensate, some water coming out there, I would think. I think we're very nearly there. That's getting hot now. I'm not sure we've got... Oh my goodness. We're nearly in business. So I think we've shut the little drain valve now, and it might have a chance of going. Aha! Isn't that absolutely delightful? It is running, and I think that the governor is doing its job, which is even more wonderful. because it's running at a sort of correct speed for a beam engine. Normally models run far too fast, but I think that this is actually doing its job. So we've got plenty of water still. We've still got over half a glass of water. That's absolutely fine. And it's running beautifully at a very realistic speed, which I think is great. What I'm hoping is that when it's run out of fuel, there's still water left in the boiler, because that's the correct way for it to be on an engine that's got no feed water to the boiler. So on Bongo, you've got fuel as long as you've got coal in the tender, and you've got injectors to put water into the boiler. But this is these model engines, they're designed as a sort of one-shot machine. So we've got hopefully more than enough water to outlast the fuel. Let's see what the whistle's sounding like. Oh my goodness. That'll scare all the local dogs. Sorry, Jinx. There's a little jet of steam coming from the safety. I don't know if you can see that. There's a little jet of steam coming from the safety valve, so that's fine. We are now at full working pressure. So now, if I open the steam valve, it'll probably be a little bit more lively, but it shouldn't run any faster because we've got a governor. So I hope you've enjoyed seeing the fun of building a small steam engine from a kit. I think it's quite charming and it runs delightfully slowly, so you can see how it all works. If you want to get one for yourself, the company's called Stirlingkit, and even better, there's a discount voucher for Peter's Railway readers and viewers, which will get you 15% off. I'll put the links in the video description. As I said earlier, I'm not being paid for doing any of this, but I have really enjoyed doing it. Meanwhile, now to find out what's in the mystery box. What is in the mystery box? So in here is a small generator, actually very beautifully modelled, because it actually looks like a generator. Obviously inside there's going to be a small modern electric motor of some sort, or a little generator, but it's been put into a little casting or a little machine part to look really like it should do. And so further parts are, that looks like a street lamp, and I think that's going to be the top of the street lamp. So let's put this together. Okay, so there's a street light stanchion, that's going to go in there, that's going to go on there, and I think those little screws just go in to make it look nice. Right, one small street lamp. We obviously have to feed that down through there. So that is going to go and sit in there. Red onto red, and the blue onto the output from the switch. That's pretty easy to do. Then open that one. Very neatly done, this, I have to say. Put that in there. Okay. So I guess we'll have what my friend Roger will call a sanity check here. Fantastic. Now it only works one way. I think you'd expect that because that's a DC generator and this is an LED, and LEDs only work one way. So that should be okay. Hopefully it'll go the correct way for the engine, or we'll have to reverse some wires. So what we should do, I suppose, is now to raise steam again and to see if we can drive the generator with the beam engine and generate some electricity. So I think we will see if we can get it running, and then we might try and measure the output power from the generator from the engine. I've got some mess in here and I've put some water in the boiler. So get the fire lit. That's going nicely. Put that in there. Right, and now wait for a few minutes. So we've got steam up, and I can prove that. If you put your fingers there, they will get undoubtedly a little bit too hot. So we've got steam up. Let's see if we can make it go. And it's not going too fast because the governor is controlling the speed, and we're driving the generator. What do you reckon? No, not much. We're gasping into life here. The governor, I think, is working a little bit too well. So if I take the governor drive off, we'll let it run without being governed, because I think that's just keeping a little bit too slow. So we have a little go. The governor's now disconnected, so that won't try to restrict the steam supply as the revs go up. Let's try that. That is much better. Not quite so realistic, it seems to be running rather fast, but we have now got it going. There is a slight problem, I think, with there's fresh steam, live steam is leaking to exhaust. There's a blow-by past the valve. We'll talk about that more later on. But it is running, it is generating a little bit of power there. Not very much, probably. So I think what we might do now is we might try and measure how much power we're actually making. It's going to be in milliwatts, I suspect, but let's do that. So now I've coupled up 2 meters to the output of the generator. This one's going to read voltage, so up to 20 volts. We won't get anywhere near that. And this one's reading current. So if we want to measure the power output that we're getting from the little generator, we've got to measure the voltage multiplied by the current in amps. Okay, so here we go. Throw the switch. Ta-da! Oh my goodness. Right, well we've got 3-ish volts. It's running a bit slower now. We've got a bit more current to start when it was running faster, before it ran out of steam. So we go up to... So I've changed the setting on this. That's now 0.1 of an amp, so that's 100 milliamps up there. So we're going to be somewhere down here probably. So let's just get up a bit of steam again. We want to do it unconnected first of all to get the engine running. So here we go. Right, power. Okay, so we 20 milliamps, 10 milliamps, 3 volts, and we're sort of running out of steam here. I think we're wasting an awful lot of the steam direct to exhaust. That's another little project, perhaps for tomorrow. So yes, we're not really keeping up. The steam supply is not really keeping up with the requirement to run the generator. So we just take another reading now. Open the steam valve. Full boiler pressure for a moment. Turn it on. Whoa, here we go. 3 volts-ish, roughly 3 volts it was. And, well, we need about 10 milliamps, say, something like that. It peaked at 20, perhaps, to start with. So, okay. So we'll turn that off. We don't want to waste the electricity. So, in terms of power output, that is 3 volts times, well, we say 10 milliamps. So that's 10 equals, but we've got to divide it by 1,000 to make it into milliamps. So the power output was 0.03 watts, which is 30 milliwatts, which is not a huge amount when you consider the amount of heat input that's going into the boiler. Anyway, we generated peak probably at about 60 milliwatts, and constant was about 30 milliwatts. But the part of the problem is that the boiler can't quite keep up with the engine on that load. So that's a thing for later on. So this is a beam engine, and I think we might talk for a moment about what's parallel motion. In the early days, they didn't have the machinery to enable them to make guide bars to guide the piston rod up and down in a straight line. And so the problem with the beam engine is that the beam is pivoting about here, so this end, while it's going up and down for the piston, it's also moving very slightly in and out because it's going round this point here. And so what Watt did was he created his parallel motion. And so here's the part of the beam that's attached to the piston going up and down, and then he created another point here halfway along, and so that is guiding this little point in here. And so you get between this part here and this part here, it forms a little symmetrical triangle, so that the amount that this is moving in and out is exactly compensated by that part there. And so the net result of that is, as the end of the beam goes up and down, this part here goes in a lovely straight line. So to help explain how the governor works, I've got a page in book 3, The Forgotten Engine, and Peter and Grandpa were using a traction engine to operate a sawmill, and so the idea is when you put the load on the saw, the governor helps to keep the engine speed constant, and the way it does that is when the balls fly outwards, as they fly out more, they push this spindle down, which is the valve for the steam. So when it's running at the right speed, say, the valve is partly open, steam can go through to run the engine. As the balls fly out, they push the valve spindle down and cut the steam supply off a bit. And then if it goes too slow and the balls fly back in again, then they lift the valve spindle up, and then that lets more steam go through to try to restore the speed of the engine back to the speed it's set to run at. And so although in a traction engine the valve isn't quite set up like that, on this engine it's exactly the same, because you've got, as the balls fly out, they push that little valve down there and slow the engine down. So we've had the engine running, and I think it's a lovely model. It's beautifully made, but I've got one reservation about it. I'm not very happy with the amount of steam it seems to use, and when it's running, I think you can hear steam leaking directly from the steam inlet on the engine straight out of the exhaust. And to show this, I've connected a little pipe up and I can blow. So the power stroke is down here with the piston pushing up, and then the exhaust stroke is there where it should be pushing the waste steam out of the exhaust pipe. And if I sort of suck and blow on here, you'll hear what's going on. So sucking and blowing. So you can hear straight away that the steam is leaking directly from here down to the exhaust pipe. You can hear it making a sort of shushing noise. So I think there's something wrong with the valve in the engine, and maybe the dimensions of it. So if I just take the valve out. So here's the valve that I've just taken out of the engine, and you can see there's this slot here, and there's three ports in the cylinder. One brings in live steam here, then there's a middle one that takes the steam to the cylinder, or the exhaust steam back out of it, and then there's a port here that goes down to the exhaust pipe. And I think this is so long that it's allowing live steam to find a short circuit direct from input here to out of the exhaust. So people who know me a tiny bit and have watched some of my videos will know that I'm a little bit of a perfectionist, so you won't be surprised to know that I've made a new valve to replace the one that it came with. So here's my version of the valve, and I've just made that slot rather shorter, and I did a little measurement to work out what to do. So the idea is that this will now not be long enough to allow the live steam to go straight to exhaust. So first things first, I think it's running much better than it was before with the new valve in it. You don't hear that almost constant roaring of steam being wasted to exhaust. So I don't know if the makers would like to modify the valve they supply with the engine, but the original had a gap of 10mm across there, and my modified version had a gap of 7.9mm, symmetrical about the centre there. So with the improved valve, we've got steam up again, and safety valves lifting, and we'll open the regulator and see if she'll go. I've not got the governor couple because it needs to run a bit faster to generate the electricity, so contact! So now we've got 5 volts now and 15 milliamps. 5 volts and 15 milliamps. And it's able to keep up with that much more constantly than it was before. We're not running out of steam. Last time all we were doing was running out of steam, whereas now the little boiler can keep up with the demands of the engine. How many watts is that? Get my calculator out. That is 5 volts times 15 divide 1,000, because it was milliamps we're reading in, equals, we have now got 75 milliwatts, which is more than twice what we had before. So that is definitely an improvement. So I've assembled the engine from the kit. I thought the instructions were excellent, it went together very easily, the parts are beautifully made, and I think it's a very nice model. It looks very much like a small steam engine would have looked years and years ago. I think the governor is very special and it works rather nicely. So I hope you've enjoyed seeing this little engine come together and now working beautifully, and so my next video will be back up on the big railway. Thanks for watching, and bye for now then. Bye bye.